All right, let's take a look now at example 3. Let's evaluate this limit. Well, here's one problem. If we try to use direct substitution, what would happen is I would substitute this 3 into the denominator, what we typically call q of x, and I'd have 3 minus 3 equals 0, and that would be a rule breaker. You're not allowed to divide by 0. So we have a problem. Well, one thing we can do is factor an equation. And so I'm going to factor the numerator here. It's a quadratic, which means I'm going to use x method, where I'm going to call this a, b, and c. Yes, we haven't gotten away from this. We started at the very beginning of the school year with x method factoring, and we're going to finish the year with it as well. That's right. I'll take my a times c and place it in the top of my x here. So 1 times -6 is -6, and b is -1. So I'm looking for two factors, which two numbers, we'll call it m and n, such that they multiply and their product is -6, and they add together and the sum is -1. The two numbers I'm finding here, the factors of 6 that have a difference of 1 would be 2 and 3. The numbers 2 and 3, and to make it a -1, it would need to be 2 minus 3, and I could check it. 2 times -3 is a -6. So those would be my two numbers m and n, such that they multiply, or the product is the value a times c, and their sum is the value b. So what does that mean? Well, the next step is we took a and we split its power, and we put this in parentheses. So if you split the power of it squared, you get just the power of first, x plus 2, plug in the value m, and then I again split the power. I'm splitting this power right there, and I would get x minus 3. That's going to be my numerator. So that's what we just came up with. And now what I'm going to do is slide this over a little bit and say this, all that is my limit here as x approaches 3 of this. But we can see algebraically that I could simplify that limit by canceling this out. We called that earlier this school year a removable discontinuity. It's where we got a hole in the graph. And so it looks like now we're just finding the limit as x approaches 3 of x plus 2. And that's quite simple. We can use direct substitution and just say, okay, well, that will be equal to 3 plus 2, which is 5. And so now that we know our limit, let's check it out. Here's the picture of the graph. And you can see as you approach 3 from both the left side and the right side of the graph, the y value we approach is 5. So as we approach this value 3, as we close in on the x value 3, the function itself, or the limit, is approaching the y value of 5. And so that would be our answer. So the limit, we could say that the limit, and I'm just going to call this, for being shorter, I'm just going to call it f of x. The limit of f of x equals 5. And the reason I'm calling it f of x is because that's what they called it right there. So we used factoring to simplify, so we could use direct substitution, even though originally we wouldn't have been allowed to substitute. So the same thing here, let's test it. If I did a direct substitution, I can say that this, since this is a rational function, polynomial over polynomial, I could say that it will be equal to, if I substitute that -2 in, -2 plus 2 divided by, which is going to be 0, divided by -2 quantity squared, plus 2 times -2 squared, minus 3 times, oops, I forgot the -2, minus 6. So what I have here is I will have 0 divided by -2 times -2 times -2. That's 3 negatives. It will remain negative. 2 times 2 times 2 is 8. So -8. Plus here, -2 times -2 is positive 4 times 2 is 8. Minus 3 times -2, which will be a positive 6, minus 6. You might notice this time, the 8 simplify, 6's simplify, which leaves us with nothing on the bottom. And that we can't, there's no limit there. That's undefined. So we have a problem. Well, let's try factoring. If we wanted to try to factor, what I'm going to do is factor this by grouping. So this was just using direct substitution here. So what I'm going to do is try to factor this by grouping. So at this stage, I'm going to slide this down. Oops. And so if I graph by, or if I factored by grouping, what I'm going to do is I'm going to look at these two groups individually and say, okay, what's shared in the front group? They both have a GCF, a greatest common factor of x squared. So if I pulled those out, it's kind of like a reverse distribution. If I pulled those out, I'd be left with an x in the front. X cubed divided by x squared would be x. And then 2x squared divided by x squared would be 2. Now, we can factor by grouping if it turns out that we have a shared factor over here. As I look, they both share the value. A 3 can go into both of these, and this middle symbol is going to fall straight down. So I'm going to factor out a -3. Factor out a -3, I'm left with an x. -6 divided by -3 is a +2. These two factors are shared. If they do share, what happens is you can rewrite this limit in the form, we had x plus 2 up top. I'm going to put it in parentheses for now. Since these are shared, what this means is x squared is multiplying times x squared, and -3 is multiplying by x squared. X squared is multiplying x plus 2, and -3 is multiplying times x plus 2. Since that's a shared factor there, we could rewrite it as saying the values x squared and -3 are going to multiply, parentheses means multiply, times the factor x plus 2. Now that I have it in this form, I can see that I could simplify those two factors. And so this would equal the limit of, since there's nothing left over on top, that's like anything divided by itself, though I simplified it with a line, technically is 1. Anything divided by itself is 1. Think about 5 divided by 5, 10 divided by 10, 11 divided by 11. It's always 1. So it's not a 0 here. It's a 1 over x squared minus 3. So that's going to be the limit that I'm using direct substitution on. So at this stage, I will say that's 1 over direct substitution here, -2 squared minus 3. And that to me looks like we're going to have -2 times -2 is 4. 4 minus 3 is going to be 1. The answer is going to be 1. So the limit as x approaches -2 of all of this that we had earlier, x cubed plus 2x squared minus 3x minus 6 is going to equal 1. 1 over 4 minus 3 is 1. Now let's graphically go take a look at this picture, because that was quite a problem there. If we wanted to look at this, f of x equals x plus 2 over x cubed plus 2x squared minus 3x minus 6. And we want to close out on the value -2. So we're looking at what's happening as we go to -2. We can see here that from the left side, I've typed this in correctly, I'm seeming to get a graph that's not in agreement. Okay, I see what I'm doing wrong here. I was not looking, I was thinking -2 was where this vertical asymptote is. As I kind of look here closer, I see that -2 is not the asymptote is in between. That -2 value approaches the y value 1, which is exactly what we got here. The -2 as you approach it from the left, and the right side approaches this y value of 1. So that's correct. By the way, I want to show you this. We realized that when we simplified this function, we got 1 over x squared minus 3. So I just typed that in right here. And if you graph that, you'd see that it's the same graph. It's the same exact picture as before. The difference would be on the black one, if you highlight it, when you get to -2, it'll say undefined, because that's where we're dividing by 0. But on this simplified form, if I look at the red one, when you get to -2, you won't have undefined. It'll just give you a value, which is kind of skipping over. Let me zoom in a little bit. There it is. -2, it gives me 1. So it's a little bit and kind of a neat trick there for that limit. All right, with that, I'm going to let you try one. If you need to pause the video, you can. But see if you can factor to simplify to come up with the limit. If you cannot factor it, then obviously the answer would be that the limit does not exist.